Let's go. Okay, so this is finding the most general antiderivative of that function. Now, when I say find most general antiderivative, what do you have to remember to do? Plus C. Yeah. That, if I remember correctly from last year, that is the most things that I will have to take off points for. Doing that plus C. Okay, so don't let that be you. So find the most general antiderivative. I'm going to be giving you a lot of polynomial equations on these. So remember that antiderivative, you bump the exponent up 1 and divide by that exponent. So in this case, this would be 3x to the second over 2 minus 4x. And then whenever you do not have a variable, you have to add in the x value. So that's why that minus 4 becomes a minus 4x. And then we don't forget about that plus c sitting out there on the end. So, we were calling it capital F, right? So you could say 1.5, you could say 3 halves, you could keep it as 3x squared over 2. I'm wondering what I said in my key. Let's take a look. 4951 quiz review. Yeah, I said 3x squared over 2 minus 4x plus c. Yeah. Pretty simple, right? So let's keep making it a little bit more difficult. Let's keep adding some fractions, doing some other funky stuff to it. All right, so that means most general antiderivative. That's f of x is equal to 4x to the, okay, bump it up 1/4, divide by that power, 4. Plus 5/3 x cubed over 3. We'll talk about what we do with that in a second. Minus 4x squared over 2 plus c. Plus c. All right, now let's manipulate this a little bit. Let's simplify it down a little bit. F of x equals x to the 4th plus, okay, we got 5/3 divided by 3, right? 5/3 divided by 3. Now remember that if you ever got a fraction, you want to keep, change, flip, you can do that. Because if it's divided by 3, you can say 5/3 times 1/3, keep, change, flip. So 5/9. 5/9. If I present you a problem in fraction form, please leave it in fraction form. If I give it to you within decimals, please leave it in decimals. But if I don't give it to you in any form, you can pick. See, I gave you a fraction right here, which means I want my answer back in fraction. Minus 2x squared plus c. So x to the 4th plus 5/9 x to the 3rd minus 2x squared plus c. Not so bad, right? All right, let's keep it moving. Here's number 3. Find the most general antiderivative of that function. Okay, so it's still kind of polynomial-ish, right? I just have some rational exponents that I've got to work with. So the exponent is 3/4 for my first one, and then negative 2/5 for my second one. So let's do the exact same thing that we always have done. Bump it up 1 whole unit. So this is 2x to the, so 3/4 becomes, add 1 to it, 1 3/4 or 7/4, right? 3/4 plus 4/4 is 7/4 over 7/4. Again, plus 5x to the, now I'm at negative 2/5. I want to take negative 2/5 plus 1, right? Okay, well, think about that. Isn't that 5/5? Isn't 1 5/5? So negative 2/5 plus 5/5 is 3/5. So x to the 3/5 divided by 3/5 plus c. Okay, so let's reduce that down a little bit. So 2 divided by 7/4 is equivalent to saying 2 times 4/7, so which is 8/7. So 8/7 x to the 7/4 plus, and then we've got 5 divided by 3/5, which is equivalent to saying 5 times 5/3, which is 25/3. 25/3 x to the 3/5 plus c. That makes sense? right. 3 problems down. A couple more to go. So remember that you want to think about your derivative rules and reversing your derivative rules. So be careful with your sines, cosines, tangents, things like that, your trigonometric functions. You got to remember what is the inverse of the derivative. That's your antiderivative. So what's the antiderivative of sine? What's the antiderivative of sine? Negative cosine. Yeah, negative cosine. So this would be f of x is negative 4 cosine theta, right? Minus 3x squared over 2 plus c. Plus c, right? And remember that you could always take the derivative of these things to make sure that it equals out. Like, what is the derivative of cosine? It's negative sine, right? So if the derivative of cosine is negative sine, that's going to be negative 4, right? So positive 4 sine theta. You can always work backward in the end to do that. Questions about that? I don't think this is really kosher. I don't know if this is all right. I'm looking at this problem now. I'm thinking, I don't think that's okay. I don't think I should do that. Putting a theta and an x in there, I think that's wrong. But we'll just go with it for right now. Yep. Okay. Good. All right. So let's find. Look here. I give you double prime. So now let's find the original function. If we know f double prime is 16x to the third minus 9x squared plus 10x, let's find f. All right, so let's find f prime first. Let's find f prime of x. All right, so again, bump up the power. 16x to the fourth over 4 minus 9x squared, x to the third over 3 plus 10x squared over 2 plus c. Bump it up, divide by the power. Bump it up, divide by the power. That's how it works for polynomials. So we have f prime of x is equivalent to 4x to the fourth minus 3x to the third plus 5x squared plus c. Right, just reducing that down. And now we find f, the original f. So f of x, f prime, just the original f of x, is equivalent to 4x to the fifth over 5 minus 3x to the fourth over 4 plus 5x to the third over 3 plus cx plus d. Now introduce a new variable there. We've always done c and d, but honestly, you can do whatever letters you want. But let's stick with c and d. So we could leave it like that, or you could write it as 4/5 x to the fifth minus 3/4 x to the fourth plus 5/3 x to the third plus cx plus d. Yeah. Okay, pretty simple, right? Not too bad. Just double check on that. 4/5 minus 3/4 5/3 cx plus d. Perfect. All right, let's keep it going. All right, a particle is moving with the given data. Find the position of the particle. So I'm given a of t. Now remember that you have to know that a of t is the acceleration, and to get you back to the position, I need to find the second antiderivative, right? The first antiderivative gets you back to the velocity. The second antiderivative gets you back to the position. So if a of t is equal to 7t plus 2, then I know v of t is equal to 7t squared over 2 plus 2t plus my constant. In my opinion, I think we should do decimals here, especially when we're working with speed and velocity, acceleration, and whatnot. So v of t is equal to, I don't know why my v looks so weird. So v of t is equal to 3.5 t squared plus 2t plus c. Now, remember that I'm giving you v of 0. I say v of 0 is 6. Remember that I could give you really any point to get you back to what your constant is going to be, right? I could give you any point. I could give you v of 1 is something. I could give you whatever. But what the nice thing about this is that if I have v of 0, that's going to be 3.5 times 0 squared plus 2 times 0 plus c, right? And we know v of 0 is 6, which is nice. That's going to cancel, so c is equal to 6. You know, I've been giving you problems that just say, oh, okay, so v of 0 equals 6, that means 6 is my constant. Yeah, but try to remember what that means. That means that if I plug in 0, I get out 6. So yeah, I do get my constant of, my constant is 6. If I were to give you v of 1, you know, if I said v of 1 was like 7 or something instead of giving you v of 0 is 6, then you could just plug in 1 and set it equal to 7 to solve for c. I'm just being nice to you here and giving you v of 0. So that means my full v of t is 3.5t squared plus 2t plus 6. Now we find the antiderivative of velocity, which will give us position. So s of t, which is position, is going to be 3.5t to the third over 3 plus 2t squared over 2 plus 6t plus, okay, we'll call our constant d. All right, so 3.5 divided by 3, 3.5 divided by 3 gets us 1.16 repeating. So s of t is going to be equal to 1.17, we'll round it, t to the third plus t squared plus 6t plus d. Oops. That was weird. Plus d. But we know that s of 0, the starting position is 2. S of 0 is 2. So that means that if s of 0 is 2, 1.17 times 0 to the third plus 0 squared plus 6 times 0 plus d is 2. Cancel, cancel, cancel. D is 2. Again, if I were to give you like the position at time 1, right? I said the position at time 1 was like 10 or something. Then you could just plug 1 in and set it equal to 10, solve for d, and you get your constant for your position. So all said and done, the position function is s of t is equal to 1.17 t to the third plus t squared plus 6t plus 2. There we go. Don't always just assume that the constant, or the thing that I give you is always the constant. You could really solve for anything there. Question?
Could you leave the 1.17 as like 7/6 or like 7/6 or?
Yeah, if you wanted to leave it as fraction form, that's fine. I would just, in terms of acceleration and velocity and position, it's more often going to be decimals, but you know, you do you, man. You do you. Questions about that one? Mr. Kassenheiser. Hey, we gotta get to this video first. Can you come in 5B? No, 4B.
I tried. I'm sorry.
Can you come in
I
4B?
thought it would help. I thought you'd have a nice.
Can you come in 4B?
We said that maybe we're going to take a time to watch the documentary.
Should we watch the documentary?
Yes. People, I'm going to throw out a name that you need to look up, review, admire, and respect his badassness.
This is being recorded, I hope you know.
Oh. Well, I'll be at Sheets working by Monday. People,
Pick me up an application.
Gary Robbins.
Gary Robbins. I said we're going to get into it. Don't relax, okay? This guy's a beast. Oh, just wait. Yeah, his dog's name
Is
is
it for
Gary.
that reason? Runs
See?
nonstop. He runs
His dog's name. His
Elvis
dog's
is
name
for-
Mr. Kassenheiser's dogs. And Ralph. Like, my guy. Those are not dog names. Those are like two guys.
Did you name your dog after Gary Robbins?
It might be.
Are you serious?
And guess what color it is? Orange.
What?
Gary Robbins' orange beard.
Oh, that's true. Yeah, that's true. I forgot.
Gary's a trouble.
Did you really name it after Gary?
Gary Robbins has a fond place in my heart.
But Mr. C,
Being a one-time long-distance runner, me and Gary got a pact.
isn't Gary isn't your dog a troublemaker?
Yeah, but Gary Robbins is a little bit of a troublemaker. Anybody that tries to run what he did.
That's true. All right, we'll get into that in a minute. All right, so oh, do you need to stick around?
No, I just was looking. Oh, I thought you were pulling up Gary Robbins right now.
No, not yet. We got two more problems.
The way you guys talk about him, he must have like cured cancer.
No,
He runs.
even more.
He runs
Even-
like 50 some
Even
miles.
better. Just wait, Riley. Okay. Estimate the area under the curve of f of x equal to square root of x from 1 to 3. Now, this is the question that I was getting the most questions on from the people that were reviewing this earlier. So here's what I want to say about this, is that 7 and 8 are kind of done better. Like, I think you understand them better when you do them alongside each other. It seems like they are very different problems, but they're not really in the end. Estimate the area under the curve for the graph of f of x equal to the square root of x. Now, that's our function. F of x is equal to the square root of x. That will change. The function will change. Okay? So, in the notes we looked at x squared. I could give you like a 1 over x. I could give you the square root of x. I could really give you I could give you sine of x. I could give you anything you wanted. But here's the deal. The process is going to remain the same. Now, if you don't know what the square root of x looks like, you could just graph it in your calculator. But remember that this is the square root of x. This is our most basic square root function, right? That is the square root of x. And what we're doing here is looking at it from 1 to 3. So if I've got 1, 2, 3, I'm looking at it only from those values. Now, what I'm going to do is I'm going to make a line up and a dot. A line up and a dot. A line up and a dot. I am looking, and actually I shouldn't have done that middle point as of yet. Let me go back here. A line up and a dot. So basically what I'm looking at here is I am trying to find that, right? I'm finding the area underneath the curve. And I'm doing so. Oh no, Northwood Elementary is calling me. That's my daughter's school. I gotta take this. Hello? This is. Yes. Okay. 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 Do you need me to come and pick her up? Okay. Her sister has been, and I've been a little bit ahead of it, had a little bit of a cold, so it doesn't surprise me. Okay. Yeah. All right. Well, I know. I can pick her up. Yeah. Okay. I will come as soon as I can. Okay. Thank you. Bye. Oh, shoot. My kid's sick. All right. I got to do this quick then.
I can take over the class.
I got to do this quick.
No, he can't.
Yes,
All
I
right.
can.
I'm sorry, we're not going to be learning about Gary Robbins today. No. Okay, so maybe Friday. We'll see. Okay, so I've got 4 approximating rectangles. So if I want to draw in my 4 approximating rectangles, I've got to use these points. So this is 1, 2, and 3. This is 1.5 and 2.5, right? Okay. So I'm going to draw in these 4 strips. Do you see them all here? 1, 2, 3, and 4. Now, it depends whether I'm using left side or right side approximation. So left side approximation means that point right there is the left side of the rectangle. Here to here. Here to here. Here to here. Here to here. Okay? So those are the rectangles that I'm going to use. Now, when I find that left side approximation, that L4, right? That's how we know that it's left side approximation with 4 values. I'm going to take my width of each strip. What's the width of each strip? 0.5. Times the sum of my heights. The sum of my heights. All right. Now the heights are the y values. Okay, so the y values are the square root of 1, the square root of 1.5, the square root of 2, the square root of 2.5. Am I going to use the square root of 3? No, because none of my heights are the square root of 3. Okay, so I'm going to just cheat and say 2.976. 2.976. That's L4.
That's all.
Oh, that's R? Oh, that's R. I lied. I looked at the wrong one. 2.610. Is that better? Now, I'm going to do that exact same thing, but instead of left side, I'm going to use right side. Oh, it didn't clone everything. Okay. I'm just going to sketch this in again. Here is 1, 2, and 3. And my values here 1, 1.5, 2, 2.5, and 3. Now, my rectangles are now going to become the right side of each graph. Here to here, here to here, here to here, and here to here. Right? Do we see that now? So R4 is going to be the width times all of my heights of these rectangles. Am I going to have a rectangle with height at 1? No. The first one is 1.5. Plus, not a comma. Square root of 2.5, square root of 3. Those are my 4 strips, which has the total R4, what was it? 2.976. Okay. Questions about that? That's my left side and right side approximation. Yeah.
So on the test, will you ask us just to show left side and right side, or?
Yep.
Okay, and then do we always have to go down to how many sections do you want us to split it into?
It tells you, like this one said, 4 sections.
Okay. All right.
Yeah. Questions about that? Okay, so my last one, I'm going to try to do this a little quickly here. This is giving you a table of speeds and times. Now think about this. For this half a second, I can either apply that to the 0 or the 6.7, right? Because like if I'm driving and I figure out that or whatever, this is running or whatever, from 0 to 0.5, that first half a second, it's got to be somewhere in between 0 and 6.7 speed, right? So I could either apply that to this, which means I need to apply that speed to this, that speed to here, that speed to here, that speed to here, and that speed to there, right? That's really similar to left side approximation. Because am I using the 15.3? No, just like I didn't use the 3. So when I run those numbers, like I do the total distance is going to be my time times all of my velocities added up. 0, 6.7, 9.9, 12.2, 13.6, and 14.7, which comes out to be 28.55. And then I do the exact same thing.
Do you have the homework paper?
Yeah, there's one right there. I do the exact same thing for my other option. So now what I'm going to do is I'm going to apply these to all of my upper estimations. See, now am I including 0 in my red? No. See, it's 0.5 times 6.7, 9.9, 12.2, 13.6, 14.7, and 15.3. Now I include my upper end, which ends up getting us 36.2. So do I know how far we actually traveled? No, but I know it's within a range of 28.55 to 36.22 meters. Questions about that? Okay. I am going to, I have to leave you.